Hey guys, welcome back. So today we're on our way to Ravi's place. He's got a couple standby generators for us that need a little bit of help. So I'm about 30 minutes away. So once we get there, I'll turn the camera back on, we'll get the machines loaded up and back to the shop.
All right.
So we made it. Haven't quite loaded up yet. We're just checking out this machine. It's, I think, a GE branded 20 kilowatt machine with a Vanguard in it, 993 cc. Looks very clean, but I'm told it has a problem, which is why it came out of a customer's house.
Yeah, it had intermittent starting and running issues.
Okay.
It is approximately 12 years old, 13 years old, might even be a little bit older than that. And since everyone works from home now, you gotta have reliability for power.
Yeah.
Especially in our area.
So the intermittent part, that can be difficult to figure out.
Yeah, it's one of our biggest challenges when it comes to servicing a generator and repairs is finding it, because often when we go there, it works. You turn it off, turn it back on again, and it's okay.
Yeah.
So, they make devices where you can hook it up and leave it connected and then come back later and see what was going on with it.
Okay.
So that's an aftermarket battery charger or remote monitoring. This is an aftermarket battery charger. Just seeing what the age of this unit is. No, but this is it doesn't have the manufacturer date on here. Anyway,
pretty clean machine.
Yeah, we started servicing this about 4 years after it was installed.
Okay.
So we were with it for majority of its life. But we don't know when that problem started because we inherited that problem.
Yes.
So it was always there.
Okay.
It was always an issue.
Did you ever see it doing its thing?
And it did replicate.
Yeah.
We were able to figure out what was going on, so that's why we make notes here. On the controllers, it's just like a car, right? Odometer on a car, where you can't change it. So we did replace the controller at one point at 216 hours.
Yeah.
We probably replaced the battery charger at one point and then said...
And replacing the controller did not fix it?
At that moment, yes.
Okay.
But then it continued to have other issues.
Got it.
Maybe it needs another controller. You never, But then do you keep dumping more money?
Right.
And we don't like to fire the parts cannon unless it's the last resort.
I don't either. But there's not a lot that can... Well,
fuel pressure,
a problem with the regulator, maybe the computer telling it to shut down, a bad sensor.
Bad sensor, because the Briggs do have, Briggs were a little bit ahead of their time, where they would have a emergency off at the fuel. So you could hook up our EPO, emergency power off switch, remotely to the fuel solenoid to turn it off, which is part of the new electric code.
Okay.
I might be going off a little bit off of the topic at the moment, but you could.
There's oil pressure sensors. I see a temperature sensor on the engine.
Yeah.
There could be things like if the speed is wrong or the voltage is wrong, it would shut down.
Yep, overspeed, under voltage, over voltage. There's a whole set of things that can happen. And a lot of those can be erroneous also. It could be inaccurate information, but the board is reading as wrong.
Yeah.
We see that we have some rodent infestation in here a little bit. That's all from rodents.
Oh, yeah.
So...
And, of course, the controller's right there. And
right.
Did they go under? Maybe.
They go everywhere.
Yep.
So that becomes a problem also, and that just leads to challenges, There's no keeping the mice out. Never. But you can see where they will get through there.
They could, absolutely.
They can absolutely get through there and get onto that board, which will then send a wrong signal this way. So
it's pretty clean though.
Yeah, it doesn't look too bad. But you never know, on the underside, one of the diodes or capacitors in here could just be heated up just enough where it's not right.
Yep.
There's a fuse here, high voltage fuse.
Don't touch.
Don't touch.
I see that. You just touched it. Okay.
But we've never seen that blow.
Okay.
Yeah, it's going to start and run. It was running the day that we replaced it. It actually did its weekly exercise that day.
Okay.
And it did it without a problem.
How often would you say, if it was exercising, I assume once a week, do you have any idea like how often it would mess up?
Every few weeks.
Okay.
Every few weeks.
Okay, so should we get this thing loaded up?
Try load it up, yeah.
Yep. Beautiful.
Really helps having the right equipment.
Yes, it does. Yeah, the axle's right there, so we're about 3/4.
Is your tie down?
Uh,
I think I'm on it right now.
no. The D-links?
Yeah, the D.
No, you're not on those.
Oh, no?
Nope.
Oh, so yeah, we should be good right there.
Yeah, I
Right?
think that'll do. All right, so we made it back, safe and sound. So let's get this machine unloaded and bring it inside. Well, it's about a week later. Yeah, I ended up parking this in the corner because I had a few other projects to work on, and we got some snow in the meantime. So, you know, that other project is finished up, so I'd like to get this in the garage if possible. There is some snow kind of underneath the pallet, so I'm not sure how well this is going to work, but ideally we'd get this pulled into the garage, thaw it out, and then we can dig in and try to figure out what's wrong with this machine. So it's a few days later, the machine's nice and dry, so I think it's time we dig in and find out what is wrong with this machine. Now, according to Ravi, periodically it fails to exercise, but it doesn't happen often, so replicating it might be an issue. The other thing to consider too is that the issue might not be with the generator. Potentially it was with the customer's setup and their fuel delivery or their fuel supply was inadequate. Of course, there could be issues with the machine. We do have a fuel solenoid that could be bad or sticking, a regulator, and if we have some sort of a vacuum leak on the intake, that would also cause hard starting. So what I'd like to do is actually start with the engine. I want to test that, just rule that out right away, and then we can test some of the other components related to fuel delivery and see if we can't find an issue. So I'm going to start by getting the panels off. The front one can be removed as well as the side, and there's also a panel here on the back that can be removed. So we'll get those out of the way, as well as the cover and this panel, and that should give us plenty of access to troubleshoot and hopefully find the problem with this machine. Yeah, in addition to the struts, we also have some hinges back here. So it's kind of hard to see, one on each side. So I'm going to get those nuts off. And then at that point, we'll be loose and hopefully get the cover off without incident. Well, I think we're on the right track here. So removing the back cover has revealed a couple of concerning things. I guess first off, the fuel solenoid, it is damaged. It was actually damaged when this machine was uninstalled from the customer's house. So, whether it needs to be replaced or not, I'm not sure. At a minimum, we need to straighten this fitting out, turn it clockwise a bit, and test for leaks. The more concerning part is that the actual coil up here for the solenoid seems to be moving, so I'm not sure if that's supposed to be locked down or not, but I would say likely this whole thing is going to have to be replaced. The more concerning thing is actually the wiring. We have two red wires coming out of the solenoid and a ground. The ground comes right over here. It's connected to the frame, so that looks fine. We have one red wire coming over as another ground, which doesn't make a ton of sense. And the connection to ground looks pretty bad. It actually feels like it's hanging on by maybe one or two wires. Most of the wires not actually in the connector as far as I can tell. So that's an issue. We also have a relay right here, which isn't secured. And the relay, it's picking up power with this really thin gauge wire running over here. And then the output to the fuel solenoid. And we have also what looks to be dielectric grease. So definitely someone was trying to do something here. And if it wasn't done right, then for sure, this would prevent the unit from starting. So I'm going to take a second. I just want to look up a wiring diagram to figure out what each of these wires do to see if this red wire to ground even makes sense. All right, so I just educated myself on this valve, and I guess the good news is this movement is pretty normal. The only thing holding this coil on top of the valve is actually this data plate right here. And if you remove this red cap, remove the data plate, the coil lifts right off. So it can be replaced if it was damaged during the impact. As far as the wiring goes, it appears correct. The green wire with the yellow stripe, that is a ground, and the red wires are what power the coil. One wire has to receive positive, in this case 12 volts, and the other one negative, which is this wire right here. So, as it is right now, I would say that is the prime suspect. Most of the wires are not crimped in that connector, so it's going to limit the current flow, and potentially this would have trouble opening the valve. So before correcting anything here, I think I want to run a test and just see, in its current configuration, can this reliably open that valve? So before we connect up the battery, let's just make sure that we have some oil. The engine shouldn't crank, and it definitely won't start since we don't have fuel connected, but I want to make sure that at least the engine is lubricated before connecting the battery. And yeah, it might be a little bit overfilled. The oil, though, looks nice and clean, so that is good. I think we will adjust that oil level at some point, but for now it should be fine. Let's check the airbox, make sure we don't have any critters in there. Yeah, nice and clean in here. So I'm going to get actually the air filter off. I want to take a quick peek underneath and see if we have any kind of an auto choke on this machine. Because if we do, that could be another cause, why this doesn't start reliably, if that choke is stuck. All right, that's a little concerning. So all these bolts are loose. Not sure why, but I say we keep going. I don't see the auto choke. It's probably under this plate. And the fact that these are loose don't give me a warm, fuzzy feeling about what's going on here. Yeah, interesting. So there is no auto choke on this machine. There's just a throttle plate, and it is controlled by a servo. There's actually a servo over on the control panel side. There is a rod that connects over to that. So for now, I'm just going to leave this open. There's no reason to close it, but it's a pretty simple setup. We just have the breather coming in right here and the fuel right there to the mixer. Interesting. Aftermarket battery charger, Generac. So the outputs, they're connected here to the leads that go to the battery. And the other side, not sure if you can see it, but it looks like they are wire nutted and zip tied. So yeah, and actually, okay, so one lead must run up to ground. Yep. from the neutral, which is not connected either. So yeah, let's just eliminate this for now. You know, we can circle back on this a bit later. So it is a little strange to me too that there is an aftermarket charger on this. I would have thought that this had a charger in it already, so I'm gonna have to read up on that a little bit to see if this aftermarket charger is really necessary on this machine. That is some pretty serious tape. Might need to cut that back. So the battery's connected, although the display is off, so I'm not sure what to think about that. Oh, there we go. Runtime, 7.1 hours. So yeah, this board, it's not the original, and obviously at 7.1 hours, this board should still be good. And based on what I'm seeing, I'm thinking it is. So let's jump back down there and see if that fuel solenoid setup works as it is. So I'm going to unplug the control wires. These are the two that run up to the system board and energize the coil. You know, when the engine's cranking or running. So set those aside. And we will manually power this. And these connections aren't that good. At least this one, it's fitting pretty loose. Red one seems good, so let me get a new end on this. And then I think we'll be ready to test it. Okay, that is a little bit better. So I'm going to pick up engine ground from the engine. So I'm just going to use one of these alligator clips. Probably just use this bolt down here in the starter. And the red lead will be from battery positive, which should be this terminal right here. And if we connect these leads to the wires we just connected to the solenoid, that will energize it. So let me position you by the fuel valve, and let's see if it opens. All right, so we're going to connect up the negative to the relay, as well as the positive. So I've got a camera positioned down there. I don't think we're going to actually see anything move. My understanding is that there's a diaphragm right here that gets pulled up, and allows gas to travel from one side to the other. But we want to hear that this energizes, that we hear a click. And if it does, then I think we should dig a little bit deeper and just make sure that the valve is truly opening. But let's at least first test the control side. Make sure things are working, which they appear to be. You know, I heard that click. So yeah, it appears to be working. So let's actually remove the valve, test it, make sure the diaphragm's actually opening. And there's virtually no way to get a pipe wrench on here to keep from twisting out the fitting. So it looks like we're only being held on now by one bolt on the regulator. So, you know, if I get that free, we can actually move this a little bit forward and might be able to get a pipe wrench on this side. All right, I've got the coil reinstalled, and I want to test that the valve still works, being that, you know, this took on some damage and we're having issues starting. So with the coil on, but not energized, if I blow through this pipe, nothing should pass. So let's try that real quick. And no, that is sealed tight. So if we energize the valve now, that should open up. So we'll put 12 volts to this lead, negative to the other. And now it should allow me to blow through it, which it does. I'm going to do the same thing, but disconnect it midstream. Yeah. So the valve works. You know, I don't think that's the issue. The wiring is suspicious. And, well, the valve was out of position anyway due to the impact. So at least we know it's good. Let's get it reinstalled. Yeah, a little bit more. I think that's pretty good. The regulator is still loose in there, but it's lining up with the hole, so I think we can get the coil back on. Easier said than done, though. I guess we can probably pull this back out. Yeah, that's pretty good. Get the data plate back on, which is also the lock. And there's actually a spring washer down here, so you got to push down the coil and slide the data plate forward like that. So now it's locked in place. This cap is optional. Okay, good. Let's get the regulator secured next. All right, so we got that reinstalled properly. The alignment's now correct. We know that the fuel solenoid is working despite the wiring not being great. I thought for sure this was the smoking gun. Just the fact that half the strands aren't even in the ring terminal, I thought would be a problem, but apparently not, at least not in the testing that we did. So I'm going to get a new end on that. I do want to swap out this wire as well. The gauge seems a little bit thin. And this relay shouldn't be floating around down here. I'm not sure where it would have been originally, but we could probably secure it, somewhere out of the way. We'll get this wire removed. Battery's been disconnected. Otherwise, this lug would be live. I'll just use the same cord we used for testing the relay. The gauge is overkill, but it's better to go too big than the other way around. Yeah, I forgot. We're a little bit limited in reach due to these wires right here. So we could probably mount the solenoid right down low, either there or potentially right here. I mean, this is holding the regulator, but the regulator ends right there, and the rest of it's just a bracket, so that actually might work out a little better. Yeah, let's put a couple holes right there, and we'll just bolt that relay in place. So I made a modification here. Initially, I drilled that hole right there and realized it's not going to work out because there is another bolt to hold the regulator that wasn't installed, but now that it is, can't actually get on that bolt hole. So instead, I just turned it up at an angle, drilled another hole, and we'll mount it like that instead. So we'll start just by getting these control wires connected. This is what triggers the solenoid. And then we can connect the coil for the fuel solenoid. So the positive first. And then the positive feed from the start contactor. So I did swap this wire out. It occurred to me that, this is full-time battery positive, and it's plugged in right down here. So if this were to fall out, you'd end up with a lot of arcing. So I put a 5 amp fuse on there, which is overkill. Solenoid only requires 1 amp normally. All right, so that is good. Now we just need to connect the ground wires. Yeah, at this point, the wiring's looking pretty good. I checked over the rest of the machine. I don't see anything odd or suspicious going on. So for sure, this area was a prime suspect. The wiring like it was could have been causing periodic issues with the fuel valve. If this coil didn't get power when it needed it, then fuel would not be able to flow and the engine definitely would not be able to run. So I kind of hated to fix it before even trying to reproduce the issue, but we had to go through and test this valve given the hit that it took, just to make sure it still worked. And, while we're here, we might as well fix the obvious problem and get the fuel valve fully functional and ready to go. So at this point, I think we should move on. Let's check for spark and compression in each cylinder. We'll double check the valve clearance, and if everything checks out, we'll try to start it. I've got the battery reconnected, so I'm going to put an inline spark tester, and we'll check the front cylinder for spark. And I'm going to push the manual button. That should crank the engine. Okay, we've got spark on the front cylinder. Let's check the back. Okay, good. We've got spark on both cylinders. Let's check the compression. Plug looks pretty good. It is a tight gap though. And on propane, usually you see about 20 thousandths. So it's definitely less than 30. We'll double check that before putting the plug back in. As far as the compression goes, I don't know exactly what Briggs calls for on this engine, but I would expect at least 185 PSI. All right, so let's crank the engine. And we're at about 155. That seems a little low. Generac's around 200, but their engine might be built as a high compression engine to run on propane only, whereas this is more of a general purpose. So 150 might be okay. Let's check the other side. And same thing on this side. Plug looks good. Gap is tight, probably around 20 thousandths. We'll double check that. Let's see where the compression's at. And we want to see about the same, so about 150. Let's crank the engine. Interesting. So it was lower, and then the last couple cranks it shot up to 150. So I'm not sure what to think about that. Let's try this again. Now we're at 175. So the cylinders, they are uneven. And usually want it to be within 5% of each other, which, we're close, but I am suspicious of valves. So let's just double check the valves and make sure we have clearance on each valve. All right, so let's check the clearance. Briggs calls for 5 thousandths of an inch on each valve. That's plus or minus 1/1000th on either. So the exhaust is actually currently open, so we can check the intake. We'll start with the 5 thousandths feeler gauge, which is actually pretty loose. Let's try a 6. And that doesn't have much drag either, so I think we're out of spec. Let's try a little bigger. Let's try a 7. Nope, that is loose. So is an 8. Let's jump ahead to 10. And a 10 is actually tight, so yeah, for sure, this valve needs to be tightened up. I'm just going to crank the engine for a second until the intake's open, and we'll double check the exhaust. All right, the intake's open. The exhaust actually feels pretty tight. So that's supposed to be 5 thousandths of an inch as well. Let's actually start with a 2 thousandths feeler gauge. And it does not fit. So the exhaust is tight, The intake is loose for sure. We need to adjust the valves. It's interesting too. This rocker design, it's pretty much identical to the one you see on their 10-horse engines that you find commonly on the Storm Responder. That feels pretty good there. Yeah, 5 still feels pretty good. Let's just double check with the 6. Yeah, and the 6 is tight, so the exhaust valve is good. Let's crank the engine until the exhaust is open, and then we'll set the intake. Feels pretty good right there. Yeah, 5 still feels good. Let's double check with the 6. Yeah, and a 6 technically fits, but it's tight. So these valves are good. Let's see if the compression came up any. So last time we're at 150 psi. So let's see if adjusting the valves made any improvement. And now pretty much the same at 150. But the exhaust was tight, needed to be adjusted. So let's check the back cylinder and set it as needed. And for the back cylinder, I'm going to do this one by the book at top dead center. So to get to top dead center, we do need to pull this screen that covers the flywheel. And once that is removed, we can rotate the engine manually to find top dead center. And then we can set both valves. And I'm going to rotate the engine to top dead center, just a bit past. So the exhaust valve's opening, and the intake, so the piston's going down. When the intake closes, the piston's on its way back up on the compression stroke. So right about there should be top dead center. All right, so let's check the 5 thousandths feeler gauge on the exhaust. Pretty loose. How about a 6? Yeah, it's on the loose side. This valve's probably at 7 thousandths. The intake also on the loose side at 5 thousandths. And same thing with 7. So let's check an 8. Yeah, an 8's loose. And so is a 9. Let's check the intake. 8 does not fit. So the intake might be a 1,000th too large of a gap. I'm not too worried about that. But the exhaust, the 8 thousandths fits actually with no drag. So we do need to close that up just a bit. Well, if you're going to be out of spec, being out of spec on the high side is better than a tight valve, because if the valve is too tight, then you're going to lose compression. Five has a little bit of drag. Let's try a 6. A 6 has a lot of drag, and a 7 I'm guessing isn't going to fit. So good. The exhaust is in spec. Intake, close enough. And we'll just double check the compression. It should not have changed. The valves were a little loose on this side, whereas the other side, the exhaust was tight. I was kind of hoping that compression would come up a little bit on the other side, but even at 150, it should be all right. But let's double check this one, make sure we're still at 170. And yeah, maybe a touch below 170. So, good. Let's get the valve cover back on. And the gap is also pretty good. Should be a tighter gap on propane. So if this was a gas engine, we'd be at 30 thousandths, but in this case, we're a little bit over 20, which is perfect. And same thing for the front cylinder, just a touch over 20 thousandths, which is perfect. As far as I can tell, I think we're okay, as far as the compression goes. I was hoping for a little bit more. The same size engine on a Generac standby would produce actually about 200 psi for each cylinder. But this is a purpose-built engine that is meant to run on propane or natural gas. The Vanguard, it's more of a general purpose engine. They use these engines on quite a few things, and they also can run on gasoline. So because of that, I'm guessing that this is a lower compression engine, a lower compression ratio, and because of that, we're seeing the numbers that we're seeing. Now, ideally, the cylinders would be equal. In this case, they're not. We have 150 on the front, 170 on the back, but my understanding is that anything above 150 psi on this engine is considered very good. The imbalance, not ideal, but as long as we're not over 10 or 15%, then we should be fine. And in this case, we're somewhere in the middle. So I think we can move on and actually try this thing out. So we do need to wire up an outlet and connect the propane, test for leaks. And once we get that done, we'll try to start it and see how it performs. Actually, I'm not quite done in here. The way that this fuel valve picks up its ground and negative connection is just from the bolt that goes through the sheet metal. And the threads, they do rust up, like this one right here. And the sheet metal, it's actually pretty thin. So if any rust forms between the bolt and the sheet metal, then you're not going to get a good connection and the fuel valve is not going to open. So ideally, these wires would be connected to the engine block, like we have right here. And actually the battery negative runs right to the block on the other side. So that would be kind of the best way to go. And actually, when you look over here at the starter solenoid, that bolt picks up the negative that the solenoid needs, but they also ran a lead over to the block. And that is a much better and more reliable connection. So I'm going to do something similar. I'm actually going to relocate these wires to that hole right there just to get it a little bit closer. And then I'm going to jumper from this wire, which connects to the block, over to this group of wires. And that way it ensures that the fuel valve always has a good connection. All right, I think we're good at the tank. Let's double check the connection at the generator. I think we're good, at least up to the fuel valve. I do want to test actually behind the fuel valve where we redid that connection. So to do that, I actually need to loosen up the regulator so we can pull this out again. We'll energize the valve. The regulator should hold the propane back, and at that point the pipe will be pressurized so we can test the other side for leaks. All right, we now have access to the back side, and the propane is still turned on, so when I energize the coil, that will let the propane pressurize up to the regulator. And with that done, we can check for leaks now on the back side. And we might as well test the whole valve body while we're at it. Yeah, I think things are looking pretty good. I don't detect any leaks on that pipe or the valve for that matter. So I'm going to de-energize the fuel valve, resecure the regulator, and we can move on. Most standbys, they can run on propane or natural gas. So before you start a machine for the first time, you do want to double check what fuel type is selected versus the type of fuel you're going to run. In our case, we are going to use propane, and you can see that line is set in the propane position. But if you want a natural gas, you just rotate this valve to the right, and now it's metered for natural gas. Yeah, I think before I connect up the main outputs, I'm just going to take a second and clean out, some of this nesting material. I do see some nuts under here, and there's also some more debris in here, so we'll just clean that up real quick, and then we'll finish up the high voltage side of things. So we'll start just by getting the red and black wires connected. Those are going to be leg 1 and leg 2, and they go right to the circuit breaker. And then we have the ground and the neutral. So I'm going to connect these to the lugs, and then I'm going to add a jumper wire to connect ground to neutral. And usually on a standby generator, you would not want to do that because that bond should exist either in your transfer switch or your breaker box. But in this case, we are running this as a portable. So this is a separately derived system, and we need to create that bond for safety. You know, if one of the live wires touches the frame without a bond, then the circuit breaker is not going to trip. So let me get rid of these wires. These are not needed for what we're doing, and for whatever reason it looks like we need a different tool for the neutral. I'm not sure if it matters which way this goes on, but there is like a tab that sticks out. But we're going to say it goes that way. And I decided to put this back on. You know, given that we don't have an auto choke, there's really nothing to observe, you know, to see if it's functioning properly. And actually having this off might cause hard starting. You know, even if the fuel valve is open, the fuel solenoid, the regulator, it needs engine vacuum to allow fuel to advance to the engine. And with the air filter on, that's going to create a little bit more drag on the air and create a stronger vacuum down in the regulator. So we'll get all these bolts secured, torqued properly, and then I think we're going to be ready. All right, so let's give this a quick try. I've got a breakout cord plugged in. We've got a light plugged in leg 1, the kilowatt into leg 2. Now, there is air in the line, so I'm expecting the first crank to be an extended crank. Hopefully it starts. If it does, we'll double check the output. Then I'm going to shut it down. We'll try a clean start once all the air is purged and make sure it starts quickly and without issue. All right. Here goes nothing. Okay, We're getting close. I assume it's going to retry on its own. Okay, so not too bad actually for the first start. It was an extended crank. The engine did finally start and got right up to speed. We were pretty much at exactly 60 hertz. The voltage though was a little low at 115. So now that the system is purged of air, let's just try to restart it and hopefully it starts right away. And one more time. Okay, good. So it is consistently starting after about 4 seconds or so. So the big question is, did we fix it? Or is it going to continue to have problems? And, there's no real easy way to answer that question other than trying to exercise it periodically over the course of a few weeks or a few months. So I'm thinking we should probably get this back together. And what I'm going to do is roll this outside. I'll park it in the corner. And once or twice a week, I'll try to exercise it and see if we can get it to trip up. As far as the voltage goes, we were pretty close, definitely within spec, but we are down a few volts. And ideally, I would bring that voltage up to 120 volts or maybe just a little bit beyond. So likely there is an adjustment on one of these boards. I've already taken a look at this one and don't see any adjustments. But the one down here, there does appear to be an adjustment. It's that plastic screw right there in the center of your screen. So likely that will change the voltage, but until I know for sure, I'm going to leave that alone and we can revisit that later. And actually, before we move on here, I do want to do one more check. We removed the aftermarket battery charger, so I assume there is no charging of the battery even when the machine's running, but we do have a couple extra wires here connected to the battery, so I'm not sure if potentially there is another charger in the system. I'm not sure, but I'm going to start it again real quick and we'll see if the voltage goes up any. And that would be no. So we do need the external charger or the battery. It's not going to charge. Actually, now that we have some heat in the engine, let's get the oil changed. The oil didn't look bad, but it was overfilled. And I'm not sure what grade is in here. So we'll start fresh with some known good oil. Yeah, that is perfect. We are right at the full mark. It is super cold out tonight. And windy. You might actually be able to hear the wind at times. So hopefully we don't lose power. Anyway, looks like we have some extra oil. Interesting. I don't think we need to leave that in there. This machine, though, it is very clean. And I think we're done back here. So I'm just going to clean up, the little bit of dirt that's in here. We'll get the back panel on. And then we can move on to the side. I want to deal with that charger before we close that up. So we'll try to get this screen back in. I'm not sure if this is factory or not. And the reason why I say that is because, well, it just screws into essentially styrofoam. And the screws that were holding it, look like a machine screw. And they don't have a good bite into the styrofoam. So yeah, I wouldn't say it's the best fastener to hold this on, but it did seem to work. All right, now we need to figure out what to do about this right here. So previously, the battery charger was hooked up to one of the legs. So the charger was inputting 120 volts, which is fine. The concerning part is that I believe this set of wires, it would have originally been for like an optional cold weather kit where there would be like a heating pad for the battery. And I believe that only runs on utility power. So the question is, when the generator is running, is there 240 volts down here? I'm not sure, but I think we need to find out. So I'm going to strip back just a little bit, and we'll get some leads on there, connect it to the multimeter, and get the engine started. Because if this doesn't provide power when the generator's running, then I could see a run issue. The battery, it is required to run the system board, to run the servo. And if the battery runs low, then the engine will definitely have run issues. All right, so let's try this again real quick. I've got one lead of the multimeter on the neutral, and the other one is on one of the legs, on the 240 out. So like that, we should see about 120 volts if the generator is powering that 240 circuit when the engine's running. So Let's get the engine started, and hopefully we see voltage on that 240 output. So yeah, we definitely have a problem here. So even if I connect the charger back up, it's only going to charge this battery when utility power is supplied to the machine. So during an outage, no utility power comes in, battery stops charging, generator starts up, and it'll run for a while. But this board is using power, this servo is using power, and eventually that battery is going to run low, and the machine likely is going to shut down and or have problems. So yeah, something has been modified here, and we need to figure out what and get it back to how it should be. Yeah, I just spent the last couple hours trying to find like a service manual or something that describes the operation of this machine, and kind of came up empty. So I went back and watched the video when we tested to see if the battery was charging. And to be fair, I didn't give it much time. And the problem is, even though this is a propane generator, it is still producing carbon monoxide. So I can't really run it that long inside. And the weather outside for the next couple of weeks is not great. So I'm kind of limited in options if I want to move this project forward. So what I'm going to do, it's not advisable, but my theory is that this is charging. And actually, when this is running on generator power, this is receiving the 240 volts. That's what it uses to monitor the voltage and the hertz. And I'm guessing it also uses that to charge the battery, or at a minimum, run the generator systems without the need for the battery. In which case, even if it doesn't charge when the machine's running, it doesn't actually need the battery to run. The only time it really needs to charge is when it's on utility power, which is how that external charger was wired. So what I'm going to do is start the machine, and while it's running, I'm going to pull the negative off the battery. And the reason I don't like this idea is that, the throttle, it is controlled electronically. So if for some reason the machine keeps running, but we lose control of the engine speed, we're going to have to shut it down pretty quick. And before we do this, we actually do need to make a modification here. I plan on pulling this negative lead, and I did trace all these wires. I made sure that they're connecting where they should. I also tested the system board and the voltage regulator, and all the connections look good, so I don't think it's a wiring issue. But someone did install a custom red ground wire, and that's actually connected right to the voltage regulator. So when I pull the negative off the battery, the voltage regulator likely is going to lose its ground, and I'm not sure what's going to happen. So I'm going to connect this right here, or somewhere with this clean metal, and that's where it's going to pick up the ground. Now, originally, it was just picking up the ground from the frame, and I think when someone was troubleshooting, they just put a dedicated wire to it just to rule that out as a problem. So I'm going to put it up here, and we'll just clamp it in place. Like that. And we'll get this connected up. I'm not going to tighten it up, but it needs to be tight enough to be able to pull the amps it needs to crank the engine. Now, the multimeter, I have one lead on battery positive, so that is going to stay connected just like it is. And the other lead is on a source of ground. So when I pull this wire, we're still going to have a positive battery connection, which ties into the board with this wire. That should be the charge wire. And then we're going to be picking up the ground on the multimeter from this lead right here. So what I'm hoping is that the generator at a minimum stays running. And if we're lucky, once we unload the system if the charger's working, we should see this voltage jump up to something higher than 12.82. I'm not sure why that happened, but we lost control of the engine speed. And that is controlled by the main board and the servo. So I already double checked. The servo connection appears to be plugged in just fine. Really, the only change we made was moving this source of ground over here. And this is for the voltage regulator, so it shouldn't have anything to do with the engine speed. So I guess the question is, do I move that wire back and try it again? You know, I don't see that we're hung up in any way. Huh. Yeah, it seems to move just fine. So I'm going to try it again without moving that wire back. So yeah, the plot thickens. The machine cannot run without the battery, and the battery clearly is not charging, because when I pulled that off, you know, we went down to 0 volts and the machine shut down. So yeah, we definitely have some charging issues. You know, as far as the overspeed issue, potentially that was my fault. You know, when I was going through the machine, I definitely was fooling around with these wires and probably moved the location of this stepper motor right here. So, you know, maybe it just couldn't react fast enough given the position that it was in. So we're going to have to keep an eye on that. But I think the more pressing issue right now is what to do about the battery. All right, so I just want to show you one check I did, which is an important check, which is to verify that these blue wires that were connected here into leg 1 and leg 2 are making a proper connection to the system board. And we kind of know they are because the machine uses these to monitor for overspeed or overvoltage, and we did get an overspeed shutdown. So theoretically, just from that test, we know it's good. But if for some reason it's not getting the 240 volts, then of course this can't charge the battery or monitor the system properly. But let's just test and actually isolate the wires. So this is wire 12, so I'm going to unplug wire 12 from over here. And it's important to be isolated just to make sure you're not getting a connection from somewhere else you're not expecting. So from 12 to 12, we should get a beep. And we do. Let's just double check that. Yep. And the other wire, we get nothing. So that is correct. So I'm going to put wire 12 back where it was. And then the other wire is wire 11. So we'll pop that off. I'm going to put wire 12 back where it was. And we'll take out wire 11. And we'll do the same test from end to end. Make sure it's good. And it is. Kind of hard to do one-handed, but we do have a good connection there. And we should not have any connection to wire 12. And we don't. So we know that the 240 is definitely feeding into the board. The other thing we can check is the fuse that we should not touch. And, I looked at it. It didn't look blown, but I think we need to remove it and test it properly. So I'm going to get these resecured, and then we'll take a look at that fuse. And in case you're wondering, this zip tie, it's actually serving a purpose. This connector right here, which is the utility power, looks like the tabs broke off, so it's actually holding this in. So we can't really remove the zip tie, or else we risk that falling out. But as far as the fuse goes, the one that says do not touch, yeah, that worries me a little bit. Obviously, we're not connected to utility power. The battery's disconnected. Doesn't mean there couldn't be voltage in there from one of these capacitors. So, yeah, maybe I'll wear some rubber gloves. And same test, just a continuity test. Make sure it's good from end to end. And it is. So I've got to come to the conclusion that this system board, with only 7 hours of runtime, is bad. Yeah, it seems kind of wasteful to replace this just for the battery charging. But of course, it is critical that the battery does charge. So we could buy a new one of these. I think they sell for about $400 or $500. But again, this one has very few hours on it. It seems to be controlling the machine fine for the most part. But we do need to charge the battery. So that, I would say, explains why someone put this aftermarket charger on it. But of course, it only charges the battery when there is utility power. So I guess we have maybe 3 options here. Replace the controller or buy another one of these. One will be connected to utility power, and the other one we can actually connect to the generator output. And in theory, they won't overlap much, but they will overlap sometimes. Like if you're exercising the machine, there is utility power, and obviously the generator is running. So, I guess it depends on how the transfer switch handles the utility power flow. But I think, in that situation, you'll have 2 chargers charging the battery, which technically is fine. That shouldn't hurt anything, assuming that this is an automatic charger. So I'm going to have to look that up. The other option would be a relay, and we could use one charger and use the relay to select which source of power we use to power this charger. So I think either option would be viable, but I'm going to give it a little bit of thought on which way I want to go. All right, so it's actually a few days later. Got kind of the flu for a couple days, so it knocked me out of commission. And I got thinking about this issue probably more than I should have. Initially, I was kind of going back and forth with the 3 options we discussed and decided to just order a relay. And that way, when the relay is energized from the generator power, it would switch the charger over to the generator. And when the generator goes off, then it would switch back to charge using the utility power. And that would work. But the transfer switch already does that. And actually what Generac does is that they run a dedicated 120 volt circuit in addition to this 240 right here. And that 120 gets its power from the transfer switch. So when running on generator power or utility power, the charger gets power. So, I think that is the solution here. assuming that this charger doesn't work. But even that, I am not convinced. I did a little bit more digging, and I found a manual on the installation of this machine. And this is the only section that talks about the battery charging. And it simply states that the 240 utility leads, those are what the generator uses to sense a power loss. They also power the optional oil warmer and the battery warmer, and they also charge the battery. And then it just says when these leads lose power, the generator will start. But there is no discussion about how it charges when the machine is running. So I did a little more digging, and I found the wiring diagram for the transfer switch that goes with this unit. And initially, it looked pretty standard, but then I noticed something here on the output. This here is the output for the utility power. And actually, I pulled one of these fuses out just to double check it. So we'll get that back in. But right here, this is where the utility power comes out and feeds into the generator. So the utility power comes into the switch right here. And if we probe from these terminals, leg 1, leg 2, we should get continuity on these two circuits right here. The interesting thing is that when the transfer switch transfers to generator, we get something a little bit different. Let me show you. So initially, I was just looking at this to see if there was anything kind of shedding some light on the subject, and initially wasn't seeing it. We have the two outputs right here. This is the 240 out that go through some fuses and runs over to the generator. So that is the utility power, which is right here. The thing that didn't make a lot of sense is that if I actually traced these wires, the bottom one does go right up to utility supply. It goes to leg 2. This leg 1 actually comes over, and it looks like it's switched by the transfer switch. So in one position, it pulls from leg 1 of utility, and in the other position, it's not clear exactly what it's pulling, but it's coming down here to the control board. And the control board receives power from the generator and the utility. So potentially that could be sending power through one of the legs back to the generator. And the generator would still see that as a fault because both are not energized, but potentially it could just be using 120 volts actually on leg 1 to charge the battery. So to double check that, I'm just going to use the multimeter. I've got it set to test continuity. So when I touch the leads together, we get a nice beep. And if I test from the utility, leg 1 to utility output, we get a connection. Leg 2, we get a connection. If I flip this from utility, now the transfer switch is set to generator. If we check leg 2, according to the diagram, we should still have continuity to utility, and we do. But leg 1, we no longer have continuity. And I've double checked it both to the generator, leg 1 and leg 2, as well as the utility, as well as the main outputs. And there is no continuity. That wire runs over to this board. Likely, the output is probably controlled by relays or a chip on the board. So I can't say 100% for sure what it's doing, but I think we can test it. So ideally, Briggs would explain why it's switching leg 1 output to the generator, and what is it doing with the circuit board. I'm thinking that has to be the way that the battery is charging, because I don't see any other mechanism that would do it, based on everything that I've seen so far. So, technically, I guess we could test this properly and actually wire this in circuit with the generator. But that's a lot of work just to prove out my theory. So instead, I think what we're going to do is the easy thing and just supply utility power to utility A and utility B and see if that will charge the battery. And if it does, Then I'm going to kill the power to utility B and see if the battery continues to charge. And the way I'm going to do this is using this cord. It's an L14-30, so this is 30 amps at 240 volts, which is way more than this circuit needs. And that's the circuit breaker that's on my breaker panel. So what I'm doing, or what I've done, is I've also added some inline fuses here. So one of them's 2 amps, the other one's 3 amps. You know, ideally they'd be matched, but I just want to offer some type of protection. And the fuses actually in the transfer switch are actually 10 amps each. So these might immediately blow just because they're not 10 amps. But since we don't have the winter kit, I'm not expecting a battery charger to require really more than 2 amps. That's about 240 volts each. That's a lot of power for charging a battery. So yeah, hopefully they don't blow, but if they do, then I might up it a bit. And it might seem a little counterintuitive, but I'm also going to hook up the neutral. This is the output of the generator, but it's also connected to the transfer switch and the utility power. And based on the diagram, it would imply that we need the neutral in order to break out the legs for the charger. So we've got everything wired in like it should be. I've also connected up an amp clamp so we can see we're pulling 0.24 amps with the system board active, and the battery is actually sitting at a pretty good state of charge at 12.59 volts. So if the onboard charger still doesn't seem to work, we might actually need to drain this down a little bit and try again. But we've got it plugged in, circuit breaker's off, so I'm going to flip the switch, and hopefully we see that the system board starts charging this battery. Yeah, hopefully nothing too exciting happens here. I heard a click. So we're now feeding in the power, unless we blew the fuses right away. I guess we need to double check that because the battery voltage did not change at all. So I'm going to flip that circuit breaker back off and just double check the status of those fuses. So let's see if the fuses are still good here. We'll test from one of the legs over to the input. That one's good. And both fuses are still good, so nothing blew. Utility power was definitely going in, but the battery, it was not charging. So let me run the battery down a little bit, and we'll try the same test again. So I've got a decent load on the battery now. The battery voltage is at 12.08 volts. So I would think that would be enough to trigger the charger. And the current coming out of the battery, well, it says 0, which can't be right. So let's try that again. Yeah, 0.16 amps or thereabouts. So let's flip the circuit breaker back on and see if we get any power into this battery. And no, we're still at 12.08 volts. So I would say the charger is not working. And that would explain why someone wired up an aftermarket charger. So the question is the aftermarket charger enough? You know, it can only supply 2.5 amps. And I know for a fact that the fuel solenoid requires an amp. So that doesn't leave a whole lot left for the servo and the board. So I'm going to rewire things. I'm going to get it set up in such a way that we're charging with the aftermarket charger. We'll get the engine started and see if that charger can keep up the demand. All right, so the utility wiring has been removed. The load's still on the battery. We're at 12.02 volts. The difference is this time we do have the Generac charger hooked up to the battery, but not plugged in. So I'm going to plug it in, and if it works, we should see that battery voltage go up. And we'll also check the amp output from the charger. It should be about 2.5 amps. And yeah, it already went up a little bit, 12.08 volts. We started at 12.02. So it would seem like the charger is working. Let's check the output from the charger. Yeah, right at about 2.5 amps, 2.48. So that is perfect. So I'm going to get the load disconnected, and we're going to get the generator started. I want to see how much power the machine needs to operate when utility power is lost. All right, so all that extra wiring's been removed, and right now we're just checking the load without the machine running. So the control board is pulling about, well, 0.13, although these amp clamps are a little bit sensitive, so I'm not sure how much I trust the precision. Now we're at 0.24, but the point is we are well under the 2.5 amps. So we'll get the machine started, do the same test, and hopefully we're below 2.5 amps. Okay, well, that was interesting. I'm not sure what that was about. The engine was almost acting like it was getting flooded out, and then it shut down, complaining about low frequency, which makes sense because the engine never really got up to speed. So let's try to restart it, see if the issue repeats. I think there might be something wrong here with the servo. You know, we caught it once over revving, Now it's having trouble controlling the speed. And I got a quick glimpse in there, and the servo was just freaking out, just kind of moving that throttle plate, jerking it all around. And when I reach in where the servo is now and I try to move it, it actually feels nice and smooth now, but a second ago it was really choppy. So actually it feels good now. So I'm not sure why that would be, unless it was powered before and now it's not. So let's try starting it again. All right, so crisis inverted, I think, on a few fronts. First off, the charger should be more than adequate when running. We were only pulling about 1.5 amps, so that leaves an amp to spare to keep that battery charged up. The other issue, the run issue, the engine was having trouble getting up to speed, and although I was a little bit suspicious of that servo, it was in wide open throttle position, and the engine just wasn't getting up to speed. Luckily, it did restart, at least long enough to test what the power demand is of the system. But then, after shutting the camera off, I tried it a few more times, and it would not do anything other than sputter. It would not get up to speed. I tried about 6 or 7 times, nothing. So what I did was actually turn the propane tank off, disconnect the regulator, screw it back in, turn the valve back on, and it runs and starts perfectly now. So likely it was just an issue with my tank and not with the machine. So now that we know what we know, this charger is viable. I would say the installer just needs to run a dedicated wire from the transfer switch to keep that active, both when in standby and when the machine's running. So I'm not going to use this charger for maintaining the battery, at least not on a temporary install like we're doing right now. Instead I'm going to use this battery maintainer, which is a little bit less hacked together. We've also got an inline fuse. So what I'm going to do is leave this plate off, and we can actually feed it right down through there. And I am not a big fan of this zip tie, so I'm going to try to hold this connector in differently to make the problem a little bit less obvious. So the connector can definitely pull out, fairly easily. But a strategically placed piece of electrical tape will hold that in. You know, it's just a very tight space. But let's try it. Yep, that'll do. Yeah, I don't have the new oil filter yet, so we can revisit that later. For now, I'm just going to get the front panel on. So we're all back together, the machine cleaned up real nice, and hopefully it stays together. I'm hoping we don't find any issues with the extended tests that we're going to do, but time will tell. So bi-weekly, I'm going to start this machine and I'm going to record it. Most of the testing you will not see unless there is a problem, hoping there's not. But, based on what we've seen so far, I think that is wishful thinking. Likely something will come up. So one thing I'm going to do before starting any testing is actually just swap out the regulator we were using with the one up here just to rule that out. And I'm also going to use a different propane tank as well. Now, I was going to roll this outside and do extended exercising of the machine, but that is not an option right now. The manual forklift will not go through this stuff. We got a bit more snow since the last time you saw, and the temperatures are not too good either. So I think it's going to be at least a couple weeks of exercising, shorter runs inside, and hopefully things improve a bit and we can get it outside for the remaining tests. Well, it's only a few hours later and I'm not going to test it yet, but it occurs to me I forgot something. I did notice a problem by the regulator way back in the beginning and didn't think too much about it, meant to correct it, but the more I think about it, potentially the bigger the problem might be. Now, the way this usually runs is with the lid down. The engine has a fan, it's pulling air in. The rotor has a fan, it's pulling air in. So the inside of the machine, it is a kind of a higher pressure environment, and that higher pressure eventually finds its way out right here. But Briggs, for whatever reason, and I've got to think it's a good reason, they actually ran a tube over to the regulator. And you can kind of see it right there. It's supposed to be plugged in to the regulator, and it's not. But when you plug it in, that's actually the vent or the atmospheric reference for the regulator, and that tube runs over into the side compartment right here. So not having that plugged in could affect the air-fuel balance and cause problems. And we've seen a couple. First off, which I haven't focused on too much, is that anytime I run this machine, there is a ton of carbon monoxide being produced, and there really shouldn't be on propane. If the air-fuel mix is right, then it should be very low, but the fact that it's high, it is suggesting that there is too much propane getting into the engine. And we kind of saw that too, that one time the engine kind of sputtered and never got up to speed. It sounded like, a gasoline engine with the choke on. I think it was just getting too much fuel. So, potentially we do have a regulator problem, or the problem might be that that tube is not plugged in. So I am going to plug it in and hope for the best. Tube's been plugged in. Not sure you can see it. It's actually on the side of the regulator closest to the engine. So what I'm going to do is actually start it like it is. I just want to make sure that everything is pretty much status quo, and then we'll let it sit for 3 or 4 days. Well, I'm going to have to give it a minute for the carbon monoxide to clear, but I think we do have some problems here with the regulator. So I think we do have a problem here with the regulator. This time we had a new tank, a different external regulator, but we had the same internal regulator, which is a Garrettson KN. And those are very good regulators. They are rebuildable, and some of them are adjustable. In this case, we only have two settings, propane or natural gas. And we're in propane mode. Now, technically, I could remove that block and put in an adjustable valve, and we could tune this right in. But, I guess the question is the problem the regulator or the metering of the fuel? I'm not sure. And this machine, it's not a cheap machine. Ideally I would fix it right, which means using OEM parts and not changing things out. So I'm leaning heavily towards just ordering a new Garrettson regulator from Briggs and Stratton. So likely that's what I'm going to do. Besides the carbon monoxide, we had an extended crank. It did finally start, but the engine didn't sound right. It kind of sounded like it was misfiring. And even when looking at the engine was shaking. So again, I think it's fuel related. It could be spark, but based on all the other symptoms, fuel is the likely candidate. Well, it's a couple weeks later, and I've been kind of going back and forth as far as how I want to deal with this problem. I was leaning heavily towards rebuilding this regulator, but then I realized the load block on top, you can't buy it separately, and potentially that's the problem as well. So instead, I decided to just pull the trigger, order the OEM part. I think it was about $370, and that would have come with a new regulator and a new load block. But Briggs promptly canceled that order. So apparently you can't buy that part new anymore. So I did the next best thing, which is find the correct part used on eBay, advertised as good. Whether it actually is good, I guess that is to be determined, but we're going to find out. So, likely I'm not going to record removing the old one. You've pretty much seen everything there is to see down there. We just need to remove the fuel valve, unbolt the regulator, get the old one out, get the new one in, and then we'll try it out. All right, so get the regulator off. And one thing worthy of note here is that if you look in the tube right about there, there does appear to be some debris. Now that would for sure cause an issue, but this tube was disconnected up until the very last test. So that would not explain kind of what we've been seeing all along. Let me see if I can blow this stuff out. And now it's stuck in there pretty good. Definitely a restriction, so I can see why someone unplugged that. And I guess the real question is, did that bug make a nest inside the regulator? Because that would cause a run issue. So yeah, we'll open this up later and take a look. Yeah, it could be something as simple as that. So we are all installed. The eBay regulator went in without issue. I've got the propane reconnected, I've leak tested everything, and we're good to go. So hopefully this time the engine starts without too much issue. There is some air in the line, so it will be an extended crank, but once running, there are a few clues that we saw last time that hopefully are gone. I could hear it in the way the engine running, I could see it in the way that the engine was shaking. And of course, the carbon monoxide detectors within 40, maybe 60 seconds were rising rapidly to about 400 or 500 parts per million. So let's get the engine started and see if the issue's fixed. Okay, I think that did it. This time the engine started nice and clean. It sounded good. I did not hear the misfire. I did not see the engine shaking. And more importantly, the carbon monoxide detector seems to agree that things are better. We actually ran this longer than we did last time when the detector started alerting. And this time, it showed 0. So I think the problem's been solved. So that just begs the question, what was wrong with the original regulator? From the outside, it looks pretty good. And one thing I was going to do without opening it is actually do a vacuum test. In theory, you should be able to pull vacuum through here and cap this side off, and the vacuum should hold, unless there's an air leak. The problem is the vacuum pump no longer works. It won't build vacuum. So we're going to go in and see if we can't find the problem. So I've already loosened up this pipe. We'll just set it off to the side. And I was going to say things look good, but it's hard to see down there. Let me shine a light. It almost looks like there's a piece of dirt. I think it's okay, actually. Now that I can see it better, it just looks like a piece of brass down there. I think I just missed the smoking gun here. Initially, I thought there was some debris caught up in that valve. And after shining a light in there, I kind of dismissed it. I thought it was brass colored and part of the main orifice for the fuel inlet. But later, as you'll see, that piece of debris was gone. And although it doesn't seem like a huge deal, it is. That would have held the valve open just a bit, causing 2 problems. The first problem is that when the engine is off, that valve should be closed. And like it was, it would have allowed propane to continue flowing. In this case, not a big deal because we also have that electronic fuel valve. So the system is redundant, but when the engine's running, again, the valve can't close all the way. And although we were up to speed, we had no load on the engine, and the fuel requirements are minimal without a load. So with the valve opened just a bit, that likely would have caused the flooding condition that we were seeing. And not dirt. So that is not the issue. And there's really not a whole lot that can go wrong in this regulator. Either there's a leak somewhere around the edge here, or the diaphragm is damaged in some way. So to open it up, we just got to remove these screws, and that should reveal, hopefully, the problem. Oh, there we go. So the back side, nothing too exciting. Sometimes you can have a prime button right there, which you push from the outside. And all that does is push the diaphragm in, essentially defeating the mechanism. So there was a little dirt, nothing bad though, and the vent is right here. So there was no critter making his home back here. Anyway, the normal way that this works is that there is a spring behind this cover right here. And that spring pressure, it's putting pressure on the valve to keep it closed. And when you pull vacuum, that pushes or pulls the diaphragm in, allowing the needle to overcome that spring pressure. So the more engine vacuum you have, the more this valve opens up, and it just self-regulates. So the fact that we were getting too much pressure tells me that the valve was opening too far. And that could be due to a couple reasons. One is the spring could be damaged or potentially set wrong. And the other related to the diaphragm. So let's see if we can peel this off and take a look at the valve itself. And there should be like almost like a fork holding on to that valve. So you have to slide the diaphragm out to avoid damage. And there we go. Pretty simple device. It's just a valve, holds the gas back, and it's spring loaded to hold it like that. So the diaphragm just works to counteract that based on engine vacuum. And you might be able to get a glimpse of the spring, but from what I can see, it's intact and not broken. So potentially the regulator was fine. Maybe it's the load block that was the issue. Yeah, I mean, the diaphragm looks fine. Aside from a little bit of dirt and dust on the vent side, I don't see any rips or tears. So I'm fairly confident the diaphragm is actually fine. If it was torn, it would actually cause, I think, the opposite condition where, engine vacuum wouldn't effectively overcome the spring tension. So it would not let enough fuel in, the engine would run lean, but we were seeing a rich running condition. And there's really only one reason for that, and that's the spring right here. Either someone cranked the tension up, which there is a cap on there to prevent that, or potentially it was set wrong from the factory. So let's just pull that cap. We'll get the spring out, make sure it's not defective. But likely, if this tension was set wrong, then that's going to affect the entire balance, because if there's too much tension, then you're going to need more engine vacuum to let fuel in. And if there's too little, then the same amount of vacuum is going to let way too much fuel in. So it's really calibrating it so that at a set vacuum, you're allowing a set amount of fuel. And that balance is off. So yeah, let's see if we can get that cap out and extract the spring. And technically, you don't have to drill this out to extract the spring. You can just pull the valve from the other side. But given that the spring tension is wrong, we need access to the adjustment, which is under here. So theoretically, we could have adjusted this on the machine if this was the only problem. There's too much fuel, so we needed more spring tension to counteract the engine vacuum. Now, the screw actually doesn't turn, so I wonder if they glued it in. Yeah, actually it kind of looks like they did. So yeah, it's been set that way from the factory. I guess the question is, can we break that free? Maybe with a little bit of heat, but this is a plastic part. I think we need to pull that out first, and then we'll try a bit of heat and see if we can't get that to move. And the spring itself looks fine. It is painted red, so I'm sure that has some significance. So yeah, nothing obvious. I guess another possibility too is that maybe the spring lost a little bit of its spring. So with less pressure holding that valve closed, it would allow things to run rich. It's turning a little. Yeah, it looks like I can turn it in. And there we go. All right, so I cleaned up the threads, and in theory, we can adjust this to wherever we need to get this to run right. Now, this plug, it was sealed in there, and I don't think it was for tamper-proofing. I think it was actually more to form a seal, because this is the propane side of the regulator, so that plug can't leak. So it kind of complicates things, because originally I was thinking, potentially we could get the engine running, adjust the spring, find the right balance. But if I have to remove all the sealant to do that, then, making that adjustment while the machine's running is not very practical. And here's a look at the valve. It's in pretty good condition. The rubber showing some signs of wear, but that would not impact the way the machine runs. It would actually just impact whether the regulator leaks when the engine's off or not. In this case, we also have the electronic fuel solenoid, so we're doubly protected. Don't think that's the issue. Well, besides the new regulator, and I say new loosely, new to me, I did get a new oil filter. So I'm going to get the back panel on, we'll pull the front one off, do a quick swap, and then we should be good to go. All right, so how much oil are we going to lose out of here? Hopefully not too much. I've got the other one ready to go. Already got some oil in it. Oh yeah, we're dumping a bit of oil. Not too much though. Well, we're all back together, hopefully for the last time. And I guess that is to be determined. Now, I'm fairly confident the problem is fixed, but I don't want to rush into the load test. I think I am going to bring it outside and just test it maybe twice a week for a few weeks until the confidence level is a little bit higher that the issues are fixed. Well, it's 4 months later since that last video clip, and I've been exercising this machine weekly starting in February. So I did record the first few exercises in February and March. For the most part, they went without issue. I think only once it didn't start on the first crank attempt, but it did start on the second. So I think this is pretty much good to go, and my confidence level is high. I was ready to test this in April, but I had to complete another project on the load bank. The load bank is only capable of 10,000 watts. This is a 20,000 watt machine. So I added 2 5,000 watt space heaters in last week's video. So now we can pull up to 20 kilowatts using the load bank as well as the heaters down below. And we've also added some gauges here so we can see how much power we're pulling from leg 1 and leg 2. So the big question is, can the generator produce 20 kilowatts? Can the load bank pull 20 kilowatts? And I think the bigger question here is the propane setup going to handle it? And in its current configuration, I don't think it will. So I'm going to make one small change, which hopefully will get us over the finish line. And to get to 20 kilowatts, I do need 2 regulators. These are dual stage regulators rated at 225,000 BTU each. So together, theoretically, we can get up to 23 kilowatts. The big limitation is the tanks. They are small. Pressure drop is going to be an issue. I would say at best we have 20, maybe 30 minutes, which should be plenty for testing. The real bottleneck here is that, I combine the output of these tanks using this T. And the T has pretty much the same size opening, both on the inputs as well as the output. So we're not really gaining anything on the volume, and that is a tiny little output hole. I think that's about 3/8 of an inch. So the change I'm going to make is to swap out that T. The input sizes are the same, but the output supports twice the volume. So with that increased volume, that means we also need to swap out the line running to the generator to one that is also twice the diameter, and the fitting on the generator itself. So let's make those small changes now, and I think that will get us up to 20 kilowatts. think we're good. And with the last upgrade completed, we should be ready to try this thing out. So the load bank, it has been wired into the generator. That jumper we had earlier removed between neutral and ground. Since the load bank has that bond, we don't want to have it twice in the system. And I've also added a battery charger. So the generator is going to charge its own battery once up and running. So let's get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the voltage and the frequency. We use the oscilloscope to see what the sine wave looks like and the amp probe to measure the total harmonic distortion. If everything looks good, we'll put on a 5,000 watt load. We'll give that some time, then double it to 10,000 watts. If everything checks out, we'll go for the max of 20,000 watts. And there is some air in the line, so this will be an extended crank and maybe a hard start. And no issues at all getting the machine started. So the voltage fluctuating a little bit, around 116 to 118 volts. So hopefully that comes up under load. The THD without a load, not great. So hopefully that doesn't go up much under load. We're starting at about 4.9%, and the sine wave also not great. So let's put on a 5,000 watt load. I'm actually going to start at probably 3,000 watts. No issues. Let's bump that up to 5,000. Everything's running nice and smooth. You can see here on the meters we're pulling about 2,500 watts on each leg, and the voltage is at 116. Sine wave looks a little bit better. Take a screenshot of that. And THD, not terrible. It's at about 6.6%. So let's give this some time, and then we'll double the load. And it's been a few minutes pulling 5,000 watts. So engine speed remains good. Voltage remains about the same at 117 volts. So let's bring on a quick load of 5,000 watts, bringing the total up to 10,000. Handled that without any issue. So we're now at 10,000 watts. And the meters say we're a little bit below, about 4,800 on each leg. So yeah, pretty close to 10,000 watts. Sine wave continues to look pretty good. So we'll take a screenshot of that. And THD remains pretty much unchanged at about 6.7%. So yeah, overall, not too bad. So let's give this a few minutes, and then we'll go for the max. Alright, it's been a couple minutes. It's holding 10,000 watts without issue. So I think it's time we find out what this machine can really do. So let's bump it up to 12,000, 14,000, 16,000. It's doing it. Let's try 18,000. Yep. 19,000. And it looks like we might be just about out of power at 19,000, but let's try 20. And it's doing it, but I don't like how it's fluctuating, and the speed's a little bit low, so I'm going to back that off just a bit. maybe to 19,000. Yeah, it seems a lot happier there. So at 19,000 watts, THD, not bad, about 6%, and the sine wave looks more or less the same. So yeah, not too bad. And no issues at 19,000 watts, although with the voltage the way that it is, technically we're not at 19,000 watts. According to these meters, Leg 1 and Leg 2, they're at about 8,000 watts each. So we're actually only producing 16,000 watts. So yeah, that is not great. And the engine speed's definitely out of power. We're at 57 hertz, the voltage is low. So if possible, I want to bring that voltage up. So let's take the load off, we'll let things cool down, and then we'll shut it down. Now the governor response too is a little bit lazy. You can see when I take the load off, you know, it over revs a bit and then corrects. Anyway, we'll take all the loads off, we'll open up the control panel and see if we can adjust that voltage closer to 120, maybe 122 volts without a load. And this is the voltage regulator right here. So I don't see a potentiometer to adjust the voltage. I guess the only thing I did see was this plastic screw here. You know, potentially there's a potentiometer on the other side, or maybe it's just holding the board in place. Yeah, it doesn't turn, so it's just holding the board in place. So this one does not appear to be adjustable. So the voltage is what it is. So yeah, this one kind of mixed results. You know, I'm not sure how I feel about it. You know, it does start consistently and run. The THD wasn't bad. You know, we topped out under max load, I think at about 6%. So from that point of view, we're doing pretty well. From a horsepower standpoint, though, I don't think we're getting all the horsepower that this should deliver. But being a general purpose engine, you know, this is a lower compression engine than you would see on a similar Generac unit. And we topped out at, well, 20,000 watts according to the load bank and the labels. But when you do the math, even when we had everything turned on, we should have been at 20 kilowatts, but we were closer to 17 kilowatts at best. And then we backed that off to 19 kilowatts, which in reality was actually more like 16 kilowatts. So yeah, from a power standpoint, it's a little bit disappointing. That voltage is low and should be adjusted up. Although technically it did fine right up until the end, right when we got to the max load. So yeah, this is underperforming a bit, I would say, both on the voltage side and the horsepower side. You know, is this a problem with my setup? You know, is the propane delivery not adequate? Or is just, you know, is the machine just undersized and really, you know, it's not expected to pull 20,000 watts by design? Don't know. So let me know in the comments what you think. But for now, I think I'm done. So I hope this video helps someone. Thanks for watching.